20 to lesson 1, average speed. So just a heads up, the Pearson textbook is going to be a good reference for this course. So I'm going to say along the way, like where to refer to in the textbook. Sometimes it just explains it a little bit different. It's definitely something that would be great to go through in conjunction with the material that I'm giving you. So just keep that in mind. So what we're doing today is on page 6 of that textbook. All right, so introducing physics 20 here. I just want to give you like an outline of what physics really is. It's the ability. It's going to be two things really, and everything we're going to learn in physics 20 is something that all physicists would know, and has been really important for them to build on up until they become like nuclear physicists. Everything you'll learn involves two basic ideas: the ability to describe the physical universe using numbers and equations. You'll see, like, in the Big Bang Theory, there's a bunch of like equations on the chalkboard. But it's also going to be, done with pictures. It's going to be done with different words. But the language of physics is definitely mathematics. And one other assumption that we make in physics is that all phenomena can be described with some simple laws. So we take these like just simple laws and try to explain the world around us with those. It's definitely an assumption, but it seems to work really well so far. Okay, so in this course, what it's about is going to be these three things: the study of motion. So kinematics is going to be what we're doing first, and this is kinematics 1, the first part of it. And kinematics is really a description of what's happening. So it really means like, if I kick the ball here, where would it land down there? So we're describing motion that way. Dynamics, which is going to come next, is going to be the causes for motion. So really forces. We're going to talk about force being a cause of motion. And then energetics, that's actually similar to Science 10 when you guys learned about, work, kinetic energy, potential energy, and those things, and the transformation between kinetic and potential energy. Okay, so that's what's to come. Where's my eraser not work? Okay. So first off, we're going to start out with position, distance, and time. Just get a few vocab. So distance, seems pretty straightforward, is the linear space between 2 points. So the distance is like from there to there. We measure distance in things like meters, centimeters. Light years is a distance or a measure of distance. This sometimes gets confused with position. So the difference between distance and position is position. So if I was going to say my position is, I don't know, over here, I have to say in reference to something. So my position there is going to be in reference to this thing over here. So I'd say my position over here, I don't know, is 10 meters west, or east, I guess, because I'm on that side. 10 meters east, that's my position. So my distance is the distance from there to me. Hopefully that made sense. So position is always from a reference point, and then the distance is actually where or how far away from that reference point I am. Okay. Also, see page 13 and 14 for frame of reference discussion. Time. It seems really straightforward. Like you'd be like, oh well, yeah, time, that's pretty easy. But actually, this is actually one of the things that physicists really don't understand well at all. Like, what is it? Why does it keep going forward? Can it go backwards? They're all things we don't really know at all, right? Like, when did time start? We think maybe the time started at the beginning of the Big Bang, but we don't really know. So yeah, that's actually a bigger question than it might seem. But for our purposes, it's gonna be used just like you normally would think. So we're gonna measure it in seconds, minutes, hours, years, whatever it is that we need to measure it in. Okay, and then speed. There are two types of motion. There's gonna be uniform motion and non-uniform motion. Uniform motion means we're going to be going at a constant speed. So that means, it's going to be going really constantly at the exact same speed all the way across. Non-uniform motion is speeding up. So it's going to be, starts out slow. It's quicker, until it's going really fast at the end. So those are the two types of motions. Speed, so this is our first formula we're going to have. Speed is going to be equal to the change in distance divided by the change in time. That's what our little triangle there means. It just means change in. So whatever your final distance is minus your initial distance. Okay, time, same thing, change in time, whatever your final time is minus what your initial time was. There are three ways that the term speed is used. So uniform speed. So uniform speed would just really mean that it's going the exact same speed all the time. So it's going the same. Let's say you were on the highway and you had your cruise control set to 100, and it was like a perfect cruise control where it did never come off that. That would be uniform speed. Average speed, that's going to be, well, you're going to be going, faster sometimes, slower sometimes. Maybe like, you go through a construction zone and you're down to, 30 for a while there. What they're doing there is just taking the averages, just like you would take any average, and figuring out the average speed between all those all those different speeds you had going to Edmonton or wherever you might go. Okay, so that's average speed, and average speed formula is the one that I showed you up here. So that's going to be your change in distance divided by your change in time. And sorry, one thing I want to make really clear too, because this is going to come up, it's your total distance over your total time. So you'd have to figure out the whole distance you went and the whole time you went and then divide them. So we'll do equations with that coming up though. And then finally, instantaneous speed. So this is really if you had a radar gun, and so you had a radar gun here. So there's a guy with a radar gun, police officer. There's our car going really fast this way. Instantaneous speed would be what the radar gun picks up, right? It's going to pick up a speed at one instant. So that's our instantaneous speed. So not the average, not the uniform speed. It's going to be that speed at that one moment. Okay. And that's pretty much it. So then I'm just going to show you how to do some of these examples. So example 1 says, an object travels 510 kilometers in 4 hours. What was the average speed of the object? Now, before we get started, I just want to draw your attention to units, though. This one's going to be pretty good because we do like to typically measure things in kilometers per hour. And that's in kilometers and in hours, so it's going to be pretty straightforward. But most of the time, we'll find that we want to be in meters per second. It's just more of a common way that we like to talk about speed. But that's not always the case. In this case, we want to talk about kilometers per hour. So what I'd like you guys to do when you're doing these questions is pretty much the same thing I have here. You're going to write down what you know. So change in distance, 510 kilometers. Change in time, 4 hours. Our average velocity, and then put a question mark, because that's the thing we're looking for. Then write your formula. And I know it's probably going to seem pretty monotonous right now because we only have one formula we're using, but I guarantee it's going to get more complicated because we're going to have a lot more formulas. So write down your formula, and then plug your numbers in just in place of your letters, and then give me an answer in proper units. So we had kilometers divided by hours, so our units were kilometers divided by hours or per hour. And then please circle your answer. So that's the general form that we're going to use for every one of these questions. Number 2, an object travels 6.5 kilometers in 31 minutes. So if I just did the same thing I did above, we'd have kilometers per minute. That's not a typical way we like to write it, right? So what we're going to do is change these things into meters per second, because that's usually what we like to do. It wouldn't be wrong to go kilometers an hour either. It's just different. What was the average speed in meters per second? So what we're going to do first is I'm going to have, my change in distance. I've got 6.5 kilometers. That is 6,500 meters. So we're good for meters right now. 31 minutes. Well, I know that there are 60 seconds in 1 minute, so it's just going to be 31 times 60. So it's going to be 1,860 seconds. Now that we've got that, meters and seconds, we can put it into our formula. We've got meters over seconds. Just divide the two, and you end up with 3.4 meters per second. Here are some useful conversions. Just to remember, we know that in 1 hour there are 60 minutes, and also in 1 hour there are 3,600 seconds. If you can't remember 3,600, then it's really just 60 seconds in a minute times 60 minutes in an hour. So 60 times 60 is 3,600. but we're going to be doing lots with that, so you'll get used to it. Okay. So there will be times where you'll need to rearrange the formula where it says an object traveling at 60 kilometers an hour will travel how far in 20 minutes. So I've got velocity and I've got time. So now I'm looking for distance. It says how far will it travel. So that's distance. So I wrote down what I know here. So V average is 60 kilometers an hour. Time, I don't like time being in minutes because kilometers per minute, yeah, that's not right. I need these to be in similar units. So probably what the easiest thing to do would be to change 20 minutes into hours. And that's what we did here. So I got 20 minutes. And I'm going to kind of show you where I got this from using unit analysis. So let's go 20 minutes. So we've got 20 min. And I want to change that minutes into hours. So what I'm going to do is I'm going to multiply by something. It's going to be something over something, actually. And what I'm going to do is I have minutes up top here. I'm going to put minutes on the bottom here. And the reason why I did that is because I want my minutes to cancel. I want hours to be the thing that's remaining. So I'm going to put hours on the top. And now all I have to do is just set this ratio up. So I'm just going to say, okay, how many minutes are in an hour? Well, there are 60 minutes in 1 hour. So if I do this, I've got minutes over top of minutes. They cancel. So all I have to do now is go 20 times 1 over 60 or 20 divided by 60. That's going to give me my answer in just hours. So that's going to be 0.33 hours. Now all we have to do, so I've got that written here. Now all we have to do is start out with your formula, right? Just the normal way you do it, and then manipulate it. So we just bring t up on both sides, and we end up with 20 kilometers. So you guys can go ahead and check out the next one. Just notice that meters per second, and the second one is in kilometers. You got to do something about that. Okay, I'm going to end that video there and do example 5 on its own because this is a pretty common one that you'll need to do. Okay, see you in the next video.